Let's now consider a flat plate or lamina with uniform density that occupies a region of the plane. We'll find the center of mass of this plate, also known as the centroid. If you haven't watched the previous intro videos for center of mass, please go back and do that and then come back to this video. The center of mass is going to look similar. We have the moment about the y-axis divided by the mass and the moment about the x-axis divided by the mass, giving us x bar, y bar, the center of mass, or centroid. The calculations are a little more involved this time because the shape is irregular. To do that, we have these formulas. The one thing that's a little new is this Greek letter rho. Rho, if you've seen chemistry or maybe physics, in 2 dimensions is the mass divided by area. We can then solve this equation for mass to get rho times area, which is what we're doing here. Notice to find the area between two curves, which we've done in previous sections, we take f of x minus g of x. F of x being this curve and g of x being the lower curve. We find the area between those two curves using integration, and we multiply by rho, which is just density, and that will give us the mass. Let's find the centroid of the region bounded by the given curves. We'll start by sketching those curves so we have an idea of what the region looks like. The first curve, y equals x squared, is our basic parabola. We know it goes through 1, 1, vertex is at the origin, so it looks something like this. And then the other curve is x equals y squared. Again, that's a parabola, but it's opening to the right. Vertex again at the origin. And looks something like this. And so the region bounded by those two curves is this area here. Let's find the centroid of that region. First, we'll calculate the mass. We have rho times the integral from 0 to 1 of f of x, which in this case is the upper curve. X equals y squared. We'll need to take the square root of both sides, so we get square root of x. We want that in terms of x, minus g of x, which is x squared, dx. I didn't state it in the directions here, but we are assuming that there is uniform density. So rho we can make 1. And now we're just integrating x to the 1/2 would be 2/3 x to the 3/2 minus, then integrating x squared, we get 1/3 x cubed. And we are evaluating from 0 to 1. Plugging in the upper limit, 2/3 times 1 raised to the 3/2 minus 1/3 times 1 cubed. And then if we plug in the lower limit, we'll just get 0, so we're basically subtracting 0. This will give us 2/3 minus 1/3, which is 1/3. I'll make note of this so we can use it later. And now the moment about the x-axis. We have rho, integral from 0 to 1, 1/2 times f of x, which is the square root of x, and we want to square that, minus g of x, which is x squared, and again we will square that piece. dx. Rho again is 1, so we'll just drop that. The integral, we'll pull 1/2 out front. Square root of x squared is x, and x squared squared is x to the 4th. Here we get 1/2 times 1/2 x squared minus 1/5 x to the 5th. And we want to evaluate from 0 to 1. We now have 1/2 times 1/2, plug in the upper limit of 1, minus 1/5, plug in 1 to the 5th, and subtracting 0 is not going to change anything. That is 1/2 times 1/2 minus 1/5. This will give us 3/20. Now the moment about the y-axis. Rho times the integral from 0 to 1 x times f of x, which is the square root of x. I'm going to write that as x to the 1/2 minus g of x, x squared, dx. Again, rho is 1. We'll just drop that for now. We'll distribute the x. We get x to the 3/2 minus x cubed. Integrating, we get 2/5 x to the 5/2 minus 1/4 x to the 4th. And we are integrating from 0 to 1. If we plug in that upper limit, 2/5 times 1 to the 5/2 minus 1/4 times 1 to the 4th. And if we plug in the lower limit, we'll just get 0. Simplifying this, 2/5 minus 1/4 is 3/20. This is, again, the moment about the y-axis. Now we have everything we need to calculate the centroid. X bar is the moment about the y-axis, which we just found, divided by the mass. Earlier we found that to be 1/3. This will give us 9/20. And then y bar is the moment about the x-axis, which we found a moment ago. That was also 3/20 divided by the mass, 1/3. We get 9/20. So the centroid, 9/20, 9/20. In this example, we will again start with a sketch. Get a rough idea of what that region is going to look like. X cubed is going to go through the origin and 1, 1. It looks something like this. And then the second equation will get y by itself. Y equals negative x plus 2. So that's going to start at 2 on the y-axis and have a slope of negative 1. And then we want to also be bounded by y equals 0, the x-axis. So the region is this darkened area. Let's find the centroid. We need 3 things. We'll need the mass and then the moments about the x and y axis. Let's start by finding the mass. Rho, again, we will say is 1. We are assuming it has a uniform density. And I want to keep this in terms of x. So that means I'm going to have to split this up into 2 separate integrals. We'll look at the area from 0 to 1 and then the area from 1 to 2. So the first part, we are integrating from 0 to 1, and that is f of x, in this case x cubed, minus y equals 0 dx, plus the second integral will be from 1 to 2. And this time our function is the negative x plus 2. So we can now integrate. We'll get 1/4 x to the 4th. In that first part, we are integrating from 0 to 1 plus negative 1/2 x squared plus 2x. And this piece we are evaluating from 1 to 2. Now plugging in those limits, we'll get 1/4 times 1 to the 4th minus, plugging in 0 is just going to give us 0. Then in the second integral, we'll plug in the upper limit, 2. And then we'll subtract and plug in the lower limit, 1. Simplifying this, we'll get 1/4 plus negative 1/2 times 4 is negative 2. Plus 4. And then plus 1/2. And minus 2 times 1, that would be negative 2. Simplifying all of this, we'll get that the mass is 3/4. And I'll put a box around that just to note it for later. Next, we'll find our moments. Let's first find the moment about the y-axis. Rho, again, is 1. The first integral, 0 to 1. X times f of x is x cubed minus g of x. Again, g of x is just y equals 0. Then dx. Then the second integral is from 1 to 2. X times negative x plus 2 minus g of x, which is just 0. Let's clean up those integrands first. We'll get x to the 4th dx plus the integral from 1 to 2 of negative x squared plus 2x. Now we can integrate. We'll get 1/5 x to the 5th. In that first part, we are evaluating from 0 to 1 plus negative 1/3 x cubed plus x squared. And this we evaluate from 1 to 2. Plugging in the limits of integration, the first part we have 1/5 times 1 to the 5th minus, if we plug in 0, we just get 0. Then we'll plug in the upper limit, 1/3 2 to the 3rd plus 2 squared minus negative 1/3, plug in 1 cubed plus 1 squared. Let's go through and simplify this. We get 1/5 minus 0, then this will be negative 1/3 times 8 is negative 8/3 plus 4 plus 1/3 and minus 1. Simplifying all of that, we get 13/15. And again, that is the moment about the y-axis. Now finding the moment about the x-axis. Rho again is 1. We are integrating from 0 to 1, 1/2 times f of x is x cubed. We want to square that. And then g of x again is 0. Don't need to write that. Then the second integral is from 1 to 2. 1/2. This time we're looking at negative x plus 2 squared minus g, which again is 0. Let's go through and clean up those integrands. 0 to 1 is our integral. We can pull 1/2 out front. Let's see, x cubed squared will be x to the 6th. Then plus, again, we'll pull 1/2 out front. Integral 1 to 2. Here we need to square the binomial. That will be x squared minus 4x plus 4. Now integrating, we have 1/2 times 1/7 x to the 7th. That first part is evaluated from 0 to 1 plus 1/2 times 1/3 x cubed minus 2x squared plus 4x. And this part is evaluated from 1 to 2. Next, we'll go through and plug in those upper and lower limits. We have 1/7 times 1 to the 7th minus, plugging in 0 is just going to give us 0, plus 1/2 times, let's go through and plug in 2, and then we'll subtract and plug in 1. Running out of space. Simplifying again, we get 1/14 plus 1/2 times 8/3 minus 8 plus 8 minus 1/3 minus 2 plus 4. We now have 1/14 plus 1/2 times 8/3 minus 7/3 This will give us 5 divided by 21. And this again is the moment about the x-axis. Finally, we can now find x bar and y bar. Remember, x bar is m sub y divided by m, and y bar is m sub x divided by m. M sub y we found earlier, that was 13/15. M we found to be 3/4. This will give us 52 divided by 45. And then mx we just found. It's 5 over 21 divided by m, which is 3/4. Simplifying this, we get 20 over 63. That means our centroid is 52 over 45, comma, 20 over 63. Lots of tedious steps, but we finally got there.